This is the ForBackBench framework, which provides a benchmarking infrastructure that compares different forward chaining or chase systems against backward chaining or query rewriting systems. You can find implementation details on our GitHub or the algorithmic details on our PVLDB paper. They are linked here. The framework supports uploading new scenarios and generating data. As well as it integrates a number of common scenarios from literature with different data sizes and schema mappings. It includes several commonly used query answering systems. The user can click on the eye icon to see the details of the scenarios and systems, and the link to the original paper. The first feature is uploading a new scenario and generating data. The user can browse the required naming scheme before uploading the scenario. There are two types of scenarios, each has its required files. DL-Lite scenario requires ontology file and SPAR-QL queries. ChaseBench scenario requires two dependencies files, queries, two schema files. All in ChaseBench format. The framework will automatically recognize the uploaded scenario type from the provided files. Let's upload a scenario. The user must provide the scenario name. And upload the files. For example, here we are uploading an ontology and 5 SPAR-QL queries. The framework will recognize that is a DL-Lite scenario, and it will use the set of converters and translators to generate all files and mappings of different structure that required by query answering systems, as well as it will generate data of different sizes and convert the scenario to a cross-approach scenario that supports a number of different languages including database dependencies, TGDs in ChaseBench or rulework formats, OWL, OBDA mappings, and queries in SPAR-QL, ChaseBench and SQL formats. Once the scenario is uploaded, user sees a success message and sees the scenario in run experiment form. The second feature is run an experiment. Let's run an experiment with these settings. OWL2 bench scenario with small data size and one-to-one schema mapping, and run each query 2 times. On rapid, on top, RDFox, and rule work systems. The framework will run the experiment in the background and automatically plot the results in a graph. The running time takes from minutes to hours depending on the chosen parameters. For the purpose of this demo, we skip the waiting part, but if the user run it live, it may take longer. Here is the results page. The user can explore the results as a graph. We are coloring different phases of query rewriting and the chase process as explained in the legend of the graph. The framework computes the time of each process for each system, then takes the average time for each process over all runs and plots the graph. For example, in this particular experiment, we can see that the system on top takes a lot of time for pre-processing. But once the pre-processing is done, it can answer the query extremely fast. As well, the user can download a zip file containing all results as CSV files and the graph. Here are the results for each query and systems. For example, here is the rapid system results for query 1 and 2 runs. At the conference, the attendees are welcome to use our framework by uploading scenarios, running experiments, and see immediate results. Thank you for watching this demo.